Good afternoon, everyone. Thanks to organizers for this amazing workshop and for including my paper. My name is Discussant. I'm a PhD candidate from Michigan, and I will be joining CUHK this summer. I hope and I believe you must learn a lot from early morning's talk about personalization. And I hope you can still learn something new about personalization from my talk, because I'm going to look at a multi-stage setup. Firms want to make customers engage and purchase at every step of the customer journey. And one central tool is personalization. By personalization, I mean using a person's activities, their historical activities, or some of their demographics. And here in my setting, it affects the product they see on the website, not the ads or especially ads. Personalization generally works very well. So many companies use it in multiple stages of the customer journey. My paper specifically looks at two major stages. One is what I call discovery stage. So for example, when you open Amazon app, you will immediately see a list of recommendations. You don't have to do anything. These products are automatically there. And it's very hard to avoid or skip this. The second stage is what I call query stage. If you have specific things in your mind, then you can type query into the search bar. Then you will see another list of items. At this stage, all items are relative to the query you submitted. These two stages are very common. We can see that Amazon or TikTok or Spotify, they all go through this two-stage setup. And this discovery stage appears earlier without any user actions. While then users can actually initiate their own query. And then typically this appears later in the journey. Past literature has looked at personalization. I know some of you are in the audience, and most of this literature has looked at each stage individually. For example, personalizing this discovery stage can increase user engagement and purchase rate. Personalizing this later query stage will reduce search costs, improve match quality, and eventually raise consumer welfare. However, in a real customer journey, these two stages don't operate in isolation. The way the companies tailor the recommendation at discovery stage can affect customers' decision to type a query and their subsequent activities at this query stage. Ignoring these important spillovers may lead to suboptimal outcomes. And this treating each stage individually is also a common practice in industry. When I talk to many companies, they argue because these different stages were operated by different teams, they may have their objective function or metric that is different from other team. Then they tend to only focus on each engagement or revenue within their own stage without looking at the entire customer journey holistically. But I want to point out there could potentially be a problem if you ignore these important spillovers or interactions between these stages. Let me give you a simple example. For example, last time I searched or clicked some Nike running shoes, but I didn't purchase for some reasons. This time, I again open Amazon app, then likely I'll see some Nike running shoes when it is personalized because this is based on my past history. On the one hand, if I like one of the running shoes, then that's great. I can just purchase immediately. There's no need for me to keep typing query to go to the later stage. Then I'm done, then I purchase and leave. But this simply means I use these two stages as substitute. It may shift what I would otherwise buy later to the earlier stage, and eventually will not change the total revenue, because if I end up buying anyway, then I just move the timing of the purchase. But More interestingly, if I don't like any of the products, I may use what I see at the discovery stage to make inference about the products that the platform can offer. If I know these are already tailored for me, then I don't like any of these Nike shoes. And this is exactly what I'm looking for. So I may think, oh, this platform may not be capable of offering good match. Then instead of continuing the journey, I may just leave. I may browse other websites or decide not to purchase at this time. But if I do continue the journey and type my intent through the query, I may otherwise find what I like in the later query stage. This means eventually there could be a lower revenue because of early exit of customers. But of course, this is just one example. In practice, more personalization could be better, and it's an empirical question, so I want to study it in my specific context. Specifically, I asked the following research question. Simple, how to optimize multi-stage personalization in the customer journey. Before diving into the details, let me give you a quick preview of my results. First, I find applying personalization to every touch point of customer journey is not always optimal, especially when customers make inference about the product they see earlier. Then if that doesn't match their preference or demand perfectly, they may just leave without purchasing. And second, personalizing every customer is not always optimal. There is a heterogeneity in responses to personalization. Well, some customers respond very positively and strongly to personalization. Then giving them personalized experience works well. But there are some customers who prefer popularity-based general experience. Then personalization to these kind of customers may actually backfire. So what I'm proposing here is to personalize personalization. And a simple starting point is just to shut down personalization for some customers. And for the purpose of this talk, I'll mainly focus on personalization at a stage level. If I have time, I can share some insights on personalized personalization.
Yes, clarification question. You basically said what I wanted to ask as well, but like we personalize only for some customers, right? So that's in itself is a personalization. So how do you choose some customers? How do you choose the customers for whom you do not personalize?
Yes. So in some sense, we can also think that's different levels of personalization.
Yeah.
So to choose that, you will just evaluate their responses to personalization. If you gave them personalized treatment, but they're not very responsive, then you decide to not.
So that's what it means.
Yeah.
Can I ask a question? I'm just trying to philosophically understand this. I don't know what.
I'm hard.
Just trying to understand.
I know something about.
I always get bullied. That's fun. So, coming back to the question, you're saying for some people it's not worthwhile to personalize. Is it because, for instance, I don't know their preferences well enough to personalize, or is it because anything is personalized, right? I can give you crowd fakes or whatever, whatever the crowd's like. That's personalized for you. You like that, right? Is it because I don't have enough data, so you think personalization is not worthwhile? I actually put them in the space like they want to learn their own preferences. You put them in a place like imagine Netflix. You open it, it takes you to a rabbit hole. It's not your preference. Is that scenario that you're thinking? I don't have enough data to fit down your preferences, so let people tell me more. Is that what you're thinking?
Yes, that could be one scenario when the platform does not have enough data to learn the preference of that customer. But another scenario I'm thinking, even with enough data, I could still not perfectly predict their preference because my preference is dynamic. What I like yesterday may not will reflect what I want today. So in that case, even with perfect algorithm or data set, you still cannot know exactly. Yeah.
What do you mean by personalization?
Yeah, so personalization, what I mean is just to use your history and your demographics to give you show content that I think as a platform think you would like. So your product is different from others.
We're not thinking optimal layout of
Oh.
okay.
No, the information design or the layout the same, but just the product itself will be.
Let's follow up. What is not to personalize?
Oh, not to personalize is I'm not using your individual information. I just use others' populations, their popularity or bestseller product without knowing anything about your history of them.
The questions come about because it's also a form of personalization. You're just saying,
Yeah.
basically, if I don't use it, my own information, you just call it not to personalize.
Oh yeah, that's my definition, but we have to work on something.
Yeah, just remember that like, if someone's preference is mainstream preference,
Mhm.
then you're gonna go with what is good for the uniform policy for that person.
Yeah.
That is still personalized for that person.
That's right. That will be the ideal scenario. So I know your preference. I give you your preference of what you like, but I think I cannot really separate it from because you are mainstream like preference or you just like non-personalized popularity. Okay. So to study my research questions, I collaborate with Macquarie. This is a large online marketplace. It was originally founded in Japan and the country's largest peer-to-peer marketplace. Then it expanded its business to US about 10 years ago. And my collaboration is with Macquarie US. On Macquarie, just think of as eBay or Amazon. You can browse and purchase product from a wide range of categories like clothing, electronics, home products, and so on. On Macquarie, customers also go through these two standard stages. One is the discovery stage. This is the landing page or home page. When they open the app, they will see this list. Then they can type query into the search bar like marketing book. Then you will see a list of marketing book. I call this as two-stage setup because from the data pattern, 100% of traffic land on this discovery stage, and people do some activity at this stage. It's very hard to skip this discovery stage. And the query stage is more tailored to the current intent of customers. So not surprisingly, customers are more active. They click on more items and or spend more time at this query stage. Basically, I have access to all the individual clickstream data and all the product they see on the website. Yes.
So just a point of clarification on query stage.
Uh-huh.
Are responses to queries on a product listing page customized? In other words, if two people type the same query, they see the exact same list of items.
So in the non-personalized above, yes, they will see same stats of items, but the ranking will be different if that is personalized.
So it's customer initiated, but also platform.
Yes. So platform, after I receive your signal, then I retrieve a large set of products, but I re-rank based on my understanding. Okay, so in collaboration with Macquarie, I first used field experiments. I have two field experiments. One experiment, I have variation in this discovery stage personalization. I was not directly involved in this experiment, but I do have access to the data and had a lot of conversation with the company. For the second experiment, I designed the algorithm. I train it using historical data, and then I deploy it in the field. So I know every tiny detail about this experiment. And the ideal experiment will be like full factorial design, so that I have 2x2 design, and then I can learn the effectiveness of personalization at each cell. But unfortunately, there are a lot of constraints when working with companies. So I don't have variation in this query stage personalization. I didn't convince the company to do so, so I have to convince myself to write a structural model, which is easier actually than convince the company. Trust me. So my structural model is built on a Weissman sequential search. Typically, for this kind of model, people assume customers' decision to conduct a query is exogenous. But in my model, I endogenize this decision. And their decision to type a query design depends on their earlier experience at the discovery stage. Personalization in my setup affects both customers' belief and also their costs through the position of the product. Search models generally very challenging to estimate, so I use neural network estimators. The basic idea is to train a neural net. Then this neural net will become expert. It will learn the relationship between dataset and the parameters. Once I train this neural net, I can just simply apply it to my real dataset to get the estimated parameters.
So just clarifying question. So I think I missed it. So the first experiment is personalization, no or yes at the discovery stage, and then the experiment 2 is query stage personalization. And then they overlap. Does it mean that they overlap in a particular time period?
Oh, no.
Or
The time gap is over 2 years. So I cannot do anything from there.
oh, so those are like completely orthogonal to
Yes.
experiments.
Yes.
I see.
Okay, now let's talk about the first experiment. I'll quickly go through the design and the result. Customers were randomly assigned into either the personalized discovery stage, and these are personalized based on their history, like their browsing, their purchasing. And for the control condition, who see non-personalized discovery stage, these products are selected based on popularity or best-selling product. And then they can decide whether to go to the query stage. At that time, query stage was not personalized to everyone.
So again, just point of clarification, when you say personalized, because there's a lot of ways to personalize the green guy. Although I like to call it. Is this some sort of shrinkage approach? Because if you have limited search histories, you probably won't do very well. So like I mean, I can understand popular stuff, but if I have very limited search history, I think I would want to sort of shrink those estimators towards the popular means to group 6. My question makes sense.
You mean are you talking about
Yeah, how do you do personalization? So when you say personalization doesn't improve total revenue, there's a lot of ways to do personalization.
Yeah.
So I don't know what your personalization algorithm
So my
or is that the firm's personalization?
Yeah, for this experiment, first personalization algorithm is a deep learning framework. So they use both item level information and also individual level information. Basically, they learn which products and which user has a closest distance. Then they tend to recommend this product with.
So it's a little like collaborative, but so how do we know whether personalization doesn't work or it's just a crummy personalization algorithm that the company uses?
Oh yeah.
Yes.
Because the algorithm they are using is pretty standard in the industry. So given many companies also use this algorithm, so hopefully we will learn something. That is wrong. Here are the results. I find personalizing the discovery stage naturally increase user engagement at this stage. But customers become less likely to type their own query, and subsequent activities at the query stage also declines. In terms of total outcomes combining both stages, I find there is essentially no change in total revenue. Okay, now let's look deeper into the results. remember, I have some hypothesis at the beginning. And then I want to test in the data whether it can provide some supportive evidence. So I stratify my sample into two groups of customers. First, customers purchase at this discovery stage. I find for those who purchase, naturally, there's no need for them to go to the query stage. And the likelihood of conducting query decline, but when they're receiving personalization, there's no change in total revenue. But for customers who do not purchase at the discovery stage, I also find they're less likely to go to the query stage. This may show some evidence suggests that they may form expectation about their potential likelihood of finding match based on what they see earlier. And so if they don't purchase, their total spending also goes down.
Is it fair to say that's a speculative explanation?
Yes. I cannot directly observe their beliefs, so this is only very suggestive.
Why give one speculation when you could give any or none?
Well, I think this can rationalize my results. There could be competing hypotheses, but they will suggest opposite directions. That is not consistent with my. Or if you have some suggestion of hypothesis and
I speculate that you could diminish the credibility of your well-founded conclusions by trying to rationalize things that are not indicated by your.
Okay, now
this is
I will speculate quite a lot, so you will all see it. It's fine. My discussion will be unconventional.
Clarification question. So we the current speculation would go high at discovery stage, right? So you're saying people actually know they're being the first discovery page is personalized?
Yes.
So the experiment actually tells them.
Oh no, they didn't directly tell them, but customers can make inference. For example, if I click or search something before, then it show in my discovery stage, then I know I'm. And this is supported by one industry support saying that over 78% of customers expect e-commerce platforms to do some sort of.
You have some information on user tenure as well?
Yes.
Does Larry same way?
Because
you're making an inference that the platform doesn't have what they want. Right? So I assume if they have been around, then hopefully it happens less if I
I could, but I'm also worried because if this user doesn't have much experience, then platform may not have enough data to do personalization. So it can be a supply problem or
And so follow up on that, right? There's two hypotheses. One is that the recommendation algorithms just operate recommendation algorithm. The other is limited information. I think you raised that earlier. So what would help you by splitting people into those who have a long history with the platform and only using them in the recommendation algorithm, et cetera, is I should have a very good sense of their preferences. So somebody always has the same pair of shoes.
Yeah. I do find the heterogeneity for customers stay longer or who platform has more history, then their responsive is more positive and have longer. Okay. Now let's turn to the second experiment. For this experiment, I train the algorithm and implement this personalization algorithm. So Remember this experiment, everyone was exposed to personalized discovery stage, and unfortunately, I cannot change that. But what I did is to randomly assign people into either the non-personalized ranking or the personalized ranking in the query stage. For the, yes.
So just a follow-up question, so you said that the two assignment groups in experiment one were people who were assigned things by how popular they were.
Yeah.
And then people who had personalization.
Yeah.
If I have no purchase history, or very little purchase history, I'm in a cold start setting.
Yeah.
How are recommendations done? You would think, in the absence of any personal information, recommendations should be basically based on popularity.
Oh yeah, for user without any history or new users, their recommendations are based on popularity items. So my results should be interpreted as intent to treat. It's an underestimate of the person.
I see, but I should then, for users with almost no history, the treatment and control group see the same things.
Yeah, that's right.
I should then see no difference in across the two groups in their behavior. But they see the same.
Yeah, could be. Yes.
Well, you can check that in paper.
Yeah, I could. But here I'm showing the average effect by combining all the levels of customers.
Thank you.
Okay. So for the non-personalized ranking, I only consider item features like item category, brand, size. And for the personalized ranking, I use this exact same set of item features, but additionally add more individual features like individual demographics and their purchasing, clicking history. Because I want to make sure the differences are only caused by personalization, but not by underlying algorithm. I fix the underlying algorithm in both conditions by using lambda art. And let me give you an example. Suppose two people both had query on issues. If the person was assigned to the non-personalized ranking, then he would see a list of popular run issues. While the person in the personalized condition, you'll likely see a lot of Nike run issues if this person purchased a lot of Nike brand in the past. And I find personalizing this query stage can increase user engagement in terms of clicks, orders, and revenue at this query stage. There's no negative spillover from the later query stage to the discovery stage. So we see a boost in total revenue. To summarize these two experiments, from the first experiment, when only the discovery stage is personalized, essentially we don't see any improvement in total revenue. And second, when the query stage further becomes personalized, there's about 11% increase in total revenue. But we still don't know the value of personalizing only the query stage. It can be better, neutral, or worse, relative, depending on the magnitude of the spillovers. And because these experiments were conducted in different time periods, there will be a lot of platform changes. So I cannot directly compare the magnitude. So to evaluate different combinations of personalization strategy, I'll use my counterfactual simulations. And my simulation can also allow me to evaluate different personalization strategy, including the personalized personalization.
Yeah, this is very interesting. I'm thinking about this query stage and this discovery stage, not in this order, but in, I query for something I did not buy, and then next day I'll come back and I, land on the discovery page, which is already taking account what happened yesterday, right?
Yeah.
So that treatment in the second stage makes your first stage treatment even more salient, right? So how do we interpret the results here? Given that interaction and
Yeah, so you're thinking of multi-session. So the reason I see this discovery stage some product is because my earlier experience with query stage. I think randomization will take care of this because they will randomize at the very beginning.
Yeah, I'm not talking about the internal validity. I'm talking about how you interpret what is what is being treated?
Oh, my sense of being treated is whether you received personalization. But it could be like past history. But if that's for past history, I also click something, then if I'm in the non-personalized condition, I still see popular. So my history does not really.
I had a related question.
Yeah.
Do you see differences in session counts with key treatment and control? Explain to you.
I find there's no difference in return.
Product return or return?
Oh no, return to the platform. Okay, now I'll go quickly about this sequential search model. This is the overview of structural model. It has two stages. One is discovery stage and another experiment stage. Each stage is built on a classic Weismann sequential search. Customers can click on item, purchase a click item, and leave at any time. My model further extends this Weismann sequential search by allowing customers to switch from this discovery stage to the query stage. They will form beliefs about the product they will see later. Well, in reality, consumers may go back to the discovery stage or they can conduct another query. Because they do not represent the majority of my customers for this current version model, I do not consider these additional actions.
How do you model the set of feasible theory?
Oh, yeah. So, yes, you're right. There could be a lot of things. So I group them by using some NLP technology. So if it's similar, we are grouping to be more. Okay, customers' utility from purchasing product comes from two parts. Before clicking, they will learn some product information. I call these visible attributes, like the price and like the category. After clicking, they will review more information, and I call this information as hidden attributes. Like they will see more photos, they will know the item condition after clicking on this product. I allow for customer heterogeneity through random coefficients. Okay, now let's first talk about action clicking item. Before clicking item, customers only see the visible attributes. But these visible attributes are informative of hidden attributes. For example, if I know these products are in relative high price, then I may tend to believe they're more likely to be in new condition. Given this correlation between hidden and visible attributes, I can specify customers' belief about clicking an item or the expected utility when clicking an item. Clicking is also cost. I assume the cost depends on the position of the product. This is because customers tend to read and process information from upper left to bottom right. And I do find empirically in my data that the products that rank at the bottom requires longer time for customers to click. Customers will click on product if the expected utility is greater than the cost. Okay. Now, second action is to conduct a query. Before conducting query, customers are at this discovery stage. They only see product at this stage, but do not see any query results. Again, they can form beliefs about what they may see at the query stage based on what they see at the discovery stage. And also, this belief depends on whether the query stage is personalized or not. Personalization is also costly for customers. This is because I find, and also discussing with companies, they realize this personalization brings a problem in introducing storage latency. If you do personalization, you have to do some real-time calculation and data retrieval. This all increase backend search latency. And this backend latency increase translate into longer loading time. And customers experience longer loading time if they are assigned to the personalized condition. So personalization is not cost-free. Similarly, they will conduct query if the expected gain is greater than the cost. Yes.
Well, finish your point, but I'll.
Oh yeah, I'm done with this.
Okay. So in terms of changing the algorithm of products delivered to a customer, it's in theory, it should affect my beliefs about the next product that appears. So if you wind up sorting by price, then as I search, the next price should be lower, less than, or equal to the current price I paid.
Not necessary, because this is personalized based on multiple dimensions, not just price. It could be
Yeah, I agree.
color.
I meant it as a simple example.
Oh,
The
okay.
point
Yeah,
being, the point being, like, how do we sure sort of counterfactual variance of beliefs?
yeah, I know Persson, but she has a paper on beliefs about ranking. I do consider by construct belief at a position level. So I assume different position customer will have different.
Here, you assume like personalization increases loading, obviously, but I reported by the platform. But consumer already takes it into account, we decide whether it's or not, but how do we know?
Yeah,
Yeah.
that is a very strong assumption I'm making. But what I can do, and I'm doing this, is to assume customers do not expect any increased loading time, and I find the results pretty robust. Yeah, it's very similar when I get rid of this cost. Okay. Finally, customers will purchase. They will purchase the product among all clicks items, including the outside option. Okay, giving my structural model and my estimation strategy, I think I have time to briefly go through this neural net estimator. So we know traditionally we use MLE or moment condition to estimate structural model, but you have to specify the likelihood. Using AI, you can overcome this challenge. So I apply this to my structural model estimation. Basic idea is to train a neural net. Then this neural net is really an expert. It can recover the relationship between data set and the parameters. How this works? Well, first, I train the neural net. I observe all these items, and then through my model, I can simulate customers' decision to click a product or purchase a product. Then this simulated data set will become my training set. Then I feed this training set into the neural net. Well, neural net will learn, oh, this is the parameter and this is observed data set. Then it will cover such a relationship. Once it does, I can simply apply it to my real data set. Because my real data set has exact same structure as the simulated data set. Once it observes all these clicking and purchasing decisions, it will recover the both point estimate and also the statistical uncertainty. I validate this neural net estimator using some multi-call simulations, and my parameters can be covered pretty well. Yeah, yes.
Can you talk about how you extend the neural network, like how many different parameters, the structure to be?
Yes, I did try many different parameters, different architectures. So basically, I think a very low dimension, like 64 hidden layers, will be enough.
Or just a multi-layer?
Yes, and also vary other parameters like the fraction of train base and also different. But I think the results are pretty consistent, even with more complicated networks. Yeah, so it's very simple one that you can get the estimate.
Okay, good data for. Yeah. complicated data structure, right?
Yeah, it's through simulation. I basically construct 20,000 simulations. Yeah, it's manageable in high. I use the cloud computer.
Can I ask, sorry, I might have missed this, but the motivation for the neural net, is this like an efficiency argument or is it to sidestep some like computational? Computation.
Yeah. But I have to say, it's still kind of expensive in terms of computational power. Okay. In my counterfactual simulation, I use utility-based framework to rank products because I want to make sure both stages and both conditions are giving the same underlying ranking framework. And for the personalized one, I use individual preference estimated from the model. And for the non-personalized one, I use mean preference across all population. And I find personalizing only at this query stage gives me the maximal improvement in total revenue. So that's why I made such a specification. Oh, okay. So I still have time. I think I'll quickly go through some generalizability issue that I think I try to infer because I'm only working with one company and though I have some experiments, but basically all from one company. But how I think of generalizability, first, I think it's two dimensions. One is the setting. Well, I think Macquarie as a platform is not that special or unique because there are many similar platforms. And also the algorithm I used in this experiment are pretty standardized and many companies also use similar algorithm. But I do think there are some uniqueness of my setting. For example, these are peer platforms. So basically you and me can sell our pre-owned products. It can be new or used condition. So for instance, I compare the effects of new product versus used products. Then I can try to extrapolate some insights for like Amazon, they all sell items in new condition. And I can also leverage heterogeneity across categories to see how whether and how it can change the result. Okay, so my paper, the point I'm trying to make is to make such awareness. Many companies just think, oh, naturally they want to do more personalization, the more the better. But I want to create such awareness. Sometimes the more is not always optimal, but they really need to think how customers make their decisions, how their expectation affects their later activities. But of course, this is specific to the magnitude and the effect size is specific to my platform. But I think my experimental design and the framework can be applied more general. So companies can figure out their best way of doing personalization by using similar frameworks. I don't have time to discuss personalization, but this is also a natural extension. Not everyone will like personalization. In that case, companies may start from shutting down personalization for some customers. And what they can do also is to rethink objective function. They don't want to only look at single stage outcomes, but really need to consider all the customers' reactions and their behaviors in the journey level. Okay, so hopefully you'll learn something new about personalization at some point beyond Ali's paper. And thank you very much for your time and attention.
Just.
even though I work in tech, I can't figure out the PC. Well, I still don't work on it. Really has fun, so I am. So. All right, here we go. Here we are. Okay, yeah, thanks for having me. So here comes the company view. I'm Joel, or I'm Swedish. In Sweden, we say Joel. Joel is perfectly fine. I always say my name in different ways. My girlfriend hates that, but that's what I do. So the great paper it is. I'm very happy I got invited to discuss it. And if anyone has any questions for me, feel free to ask them too. Some of my points might not be obvious, I think, and they're quite high level. You know, I gave a laundry list of a lot of things to use. So anyway, I think this is a very good study. It's a rigorous one. It's very timely. So I think the context is here that these two tasks, discovery, what we can call homepage personalization, and query or search, you know, go searching for what you want, has been treated as separate. And this is both the case across different research fields. For instance, computer science, where most of my colleagues come from, they call just personalization or recommendation. You know, they have a whole conference for that called Rexis that you may be aware of. And then they have what they call IR, information retrieval, right? So these are two different fields even there. And it's an ongoing effort in industry to unify this. I have colleagues who host workshops on this, but they come from a different angle. You know, these are AI CSP. You know, so it's generative models, right? They go about it very differently. They say we're going to use these models where you can, you know, kind of mash in a whole sequence of input data and you predict something, right? So that's a very different ways, and that's kind of the way industry seems to be going. And Netflix is also doing this. I know. So there is efforts to unify. This is very relevant. So I think what this paper does is, well, you heard it already, right? It has two large-scale RCTs, and then it has a structural model that goes beyond, you know, it's a Bayesian model, it endogenizes the consumer search, and it also uses some modern methods. This is all great, I think. And then what it does, it goes beyond the tested arm, right? They had this last one, the motivated structural model, and it finds these revenue maximizing policies, right? So, and I think what's good about it is that compared to, for instance, these generative model approach, or we'll see where that goes, but this kind of approach using a structural model can bring some clarity to where the gains come from, right? Instead of just showing, you know, there is this gain from doing it, you know, which I think is where this is going. So some kind of disclaimers here, or kind of orienting. These are kind of written down maybe for myself, but I decided to keep it. So I got the two things going on here. So the first is I don't really do structural models. You know, so this paper was a learning lesson for me, I have to say. But I like it. You know, I have friends who do it. I have friends who do colleagues. Yeah, they have some people who've done that. Labor background, but it's structural. I have some algorithmic game theory colleagues. You know, they don't estimate things, but it's still structural in some sense, right? But I do this kind of stuff. You know, so applying double ML, causal ML. You know, it's a very different way of thinking. Typically. But I still like this paper, but maybe my points will be a little bit reflective of that. The second is, of course, that I'm in industry. Now, happily, I don't know if that's why I got invited, but I work on homepage personalization. I don't deal with search. You know, that's a different team, which I will get to. You know, but I have some opinions there, maybe. So, but my first thing of reading this is, okay, I have this, you know, because I mostly come from like stats background. So when I read a structural model, you know, I get a little uneasy, you know, somewhere like halfway through. But I've sent most of those comments to you, so I will not bore you with those, right? But okay, what is the main argument of the paper? I have this kind of slide, and then I have kind of 3 points, 3 questions maybe. So you can see here, there's some revenue gains here, right? You have experiment 1. This is how I wrote it down. You randomize non-personalization or personalization conditional or non-personalized query, right? No gains. That's the argument. Then there's experiment 2, which is about 10th as big, right, in sample size, where you personalize the discovery, and then conditional on that, you randomize the next stage, and then you have large gains, right, which were also statistically significant. Then she runs these counterfactuals, where you know, if you do this one that was not tested, you get a revenue maximizing gain total, And then you can additionally personalize the personalization and compare to no personalization, which some people said is actually personalization. You get about the 15%, right? So it's kind of, it's not really a big different thing, but it's compared to not doing it, it's great. Then I look at this a little under the hood here, and I just here's a minor comment a little bit, but these kind of things, where they come from? They come from this regression here, right? Where this is the kind of in a footnote, I think. So here the TI is the simulated policy assignment. And this is a minor point, but I would probably like to see robustness check here. There's a big literature in econometrics. There are this log of gravity models that was, now I think 18 years later, kind of said again, that these should be a Poisson regression. You should not, this is heavily zero inflated, as far as I can tell from the paper. So I would just like to see, that's a minor point. But the bigger one is that, and this was already said, it's not really news, but you have this non-tested cell that the data has no support of. And that's the main counterfactual. The model is estimated on experiment 2 data that doesn't cover that. So the estimate, the headline results are extrapolating over both one cell and 2 years. Right. And then you have these strong assumptions as well. So I think what this says basically, or at least to me, is that the results are contingent on the model. That might seem negative at first, but I don't think maybe that's the whole story, right? So, and the way I reach that conclusion is what is really the role of the model here? And this is my question of the paper. So I basically, my points are questions about it. So there's one way of reading the paper, and this is how I would read it at first sight. And I think many of my colleagues who come from operations research and computer science would read it. This is something to be implemented. And I think that might be a very different way of reading it to how somebody with econ training would read a model, because the meaning of a model is different, right? So here, the argument, this is to be used operationally. And I would assume then, or typically think, if this is going to run in real time for users, it can be very different. It has to work. If I query 1 hour of data, I get 60 million rows. So the assumptions need to hold, at least reasonably well, or we need to know sensitivity to them. And there's one assumption in the paper, I'm not sure, I could be wrong, but it seems to be, if you're presenting a ranked list of items, which at least holds in the discovery stage, you have dependence among items. So the typical stable unit treatment value assumption, or no spillovers, shouldn't hold across items, right? Because if item J is shown here, that means item I cannot be shown here. So the payoff thing will reference that. So it's mechanically broken, but it cannot hold. So that's one thing that I don't think I would at least like to see maybe how that is dealt with. And then, of course, there's some other hacks or checks, right? That need, what is the robustness towards the priors of the model? Well, what is the influence in its parametric form? It's typical kind of, I think, how would you look at the structural model if it would actually be productionized, right? And then it's maybe the last argument here, that if you actually run it, it would probably benefit from having some kind of reinforcement learning or bandit formulation. And I initially had a slide on this. I think it would take too much that time. So I omitted it. I'm happy to talk about that can be made. But this is not just like a conjecture. There is a new literature. Some people might already know it, right? Inverse reinforcement learning is equivalent to discrete dynamic choice models. It's been shown, right? And bandit models are reinforcement learning without state transitions, right? And then you also have search models, which are optimal stopping, right? So that's kind of the equivalence here. So then we have interpretation 2, which is maybe a bit more favorable of the model. And this basically, this is a policy tool, right? So this is not something you implement. It is something you would show a product manager after some convincing of, what is the value of an economic model, right? If they don't have an economic. So it kind of then illustrates what is the unconstrained options, right? That's the value of the structural model. And since you can commit to that this is an ideal, you don't really worry so much. You squint at the assumptions, right? And the value is, this is just textbook, kind of lifted. It provides clear predictions and mechanisms. That's, what anyone would describe in a structural econometrics textbook, what the value of it is, right? And then the firm with A/B test implication, right? So they would have a treatment R, which is personalized personalization, and they would do that. But this thing would be the left-hand side here would be, made by computer scientists. It would be shown to a PM, to then A/B test it, right? That's kind of normal. So I think the point with the paper is that currently it kind of hints at both. It's almost even in the title that is doing the left. But I would say that maybe the content is more to the right. So I would maybe ask for maybe making that a little bit more clear, perhaps. And then there's the second thing. I think this may be a little bit what you talked about. So, is the objective function being optimized by the model really the firm's objective function, right? So is there ways, and this could also be read as me trying to kind of, I'm doing the right thing. We're doing the that could also how it could be interpreted. But basically, the paper models consumers as utility maximizer, taking absurd choices rational. And then why wouldn't you apply the same logic then to the firm? I can see reasons for not doing that in paper. It's hard to solve. But at least as if, is there not something, or could there not be something that kind of hinders the firm from doing this stage-wide thing? And it's really in the paper even, and you said it, right, that full factorials of the difficult to implement, the company faces operational constraint, especially, and this is definitely the case. We have different teams that manages these two tasks, and I'm not sure, how you would even convince them to work with each other, and even such a simple thing that, the homepage is optimized for engagement or broad, right? Versus in the models that do the search are optimized for relevance, information retrieval scores, right? So even committing to a single way of measuring utility or something is incredibly difficult. There's a lot of organizational aspects around this. So there's of course that, and then it's just the fact that how do you find people that are good at both? You can make arguments about the returns to division of labor, compared advantages, yeah, as I said, aligning incentives. So if you would account for these costs, maybe not in the long run, but at least in the short run, it could wipe out some of the stated revenue gains, right? And most of the gains in the paper are short run, right? So this is kind of more bringing it to practice, but I would say maybe at least influences the limitations of how you would write the paper. And then I just have a last point, and then I will let everyone go on a break. So this is me, again, kind of trying to learn about structural thinking, right? So, and I thought first, okay, this sounds cool. And then Sam in the previous discussion already, said these things, and people already today talked about partial equilibrium and full equilibrium. So, and I definitely know less about these things than people in this audience. But anyway, I think I kind of, I read this paper by Kamenika, which I guess is the good introduction to it. And I thought, well, if you look at this result again in the paper that it's coming to, which that non-personalized discovery plus discovery's revenue max, another way of saying that in kind of information design terms, and this is probably one of the purpose of the paper, but I don't think it makes it explicit, is that basically the firm should reveal more precise information once the user signals high intent, right? And the difference is though that if you think about this, in the model, only consumers are treated as endogenous or the SERP, right? So, and this may be where I'm stretching, my knowledge. I have taken an empirical IO class, but that was a long time ago. I didn't really pay attention. So it's true. And actually, I took it by another funny thing. It's taken by Greg Crawford. He went to industry too, even though he was professor. Well, he's still at USATA, but he's at Zalando now, the main economist. So he also converted. Anyway, so that's one you can look at it. I guess it's also not spelled out in the paper. But then I guess another way, if you really want to close the loop, then I found this other paper by Yao here, it's management science, that I think basically goes another step. It's an analytical paper though, it doesn't estimate things. I guess it's very hard. So what you do then is you treat it this way, right? So the firm designs the information structure anticipating user responses. So you treat the firm's personalization not as a policy that's exogenous, but as endogenous itself, right? And it can show here then that equilibrium, to get that, the full equilibrium, the firm will personalize just enough to incentivize search. So they kind of make customers indifferent, right? And they extract all surplus from that. So that's a result. And the difference over to this paper that I'm discussing now is that at this stage, the query state information depends on the consumer search, not just, you know, the kind of firms, the signal they provide, right? So a question, an interesting thing to think about maybe for you here is if these results for papers like this, that literature would generalize and how you'd actually bring that to data to kind of estimate if possible some kind of structural model. So just to close, I have, you know, it's a great paper, just a few maybe recommendations. Yeah, be explicit about what's the role of the model. Make assumptions the model shows easy to find and assess. They kind of like, you know, hidden a bit in the whole writing. I would like to see what's separate, what's supported by data versus model, maybe some qualification results, and then maybe reconsider a little bit about the implications for practice. Thank you.
Before we break, we do have this tradition to give the author 1 or 2 minutes to respond to anything they want.
Thanks, Joe. It's really great to have someone from industry. So I assure me that I'm doing something real progress. I'm not creating a project which I'm doing some other papers. Well, okay, so I think first the role of my structural model, definitely it's not for implementation, but I would think it's an offline policy evaluation because we know running experiments will be costly. If I can evaluate something I may want to deploy eventually, then I can have some insights from the simulation itself. But of course, my goal is just to help firms understand there could be a potential problems, but eventually they have to figure out their own solutions. And well, for the cost, I can, thanks for bringing up the second point. I can clarify like what are the assumptions, what are the data patterns, and then it should will hopefully make things clear. And I can do some sensitivity analysis of my model and do more robust checks for these experimental results specification as well. Unfortunately, I don't have the operational costs or all those costs varied by the firm. But so yeah, and then I think it's also firm specific, but I think the results in my simulation will be upper bound without considering all the costs. And the partial versus full equilibrium, well, yeah, because I look at very short run experimental results, I'm working on the partial equilibrium, but it will be interesting to see what will happen in the full equilibrium, especially supply side, like sellers may strategically change their price or I don't call it, that will be a future direction. But thank you very much. Yeah.